So step one, we're going to be adding mixed numbers this time with the denominator being different. And so we're adding 1 and 2/5 plus 1 and 3/9. And the denominators 5 and 9 are different. We have to find the LCM again. So I'm going to use the slide method. So I'm going to go ahead, oops, didn't mean to move that. 5 and 9 and put this into the slide. Well, we know that 5 is a prime number, but 9 is not a prime number, so we can't just write it off immediately like we've done in the past. But because 5 is prime and 5 cannot divide evenly into 9, the only number that can divide evenly into both is 1. So 1 can go into 5 and 1 goes into 9, and just like we do in any other LCM, it forms the L here. We circle all these, so it's 1 times 5 times 9, and that equals 45. So our LCM is 45. Okay, so now we found the LCM. The LCM happened to be 45. Write that over here just so we kind of remember. And so now we're going to take 1 and 2/5. So 1 and 2/5 times fraction equals fraction, where we're coming up with the new denominator being 45. And the bottom one, 1 and 3/9 times fraction equals fraction, where the new denominator is 45. Now, just so you know, I'm intentionally not dealing with the whole number right now. The whole numbers will get added into in the end, but I'm just dealing with the fractional part of this right now. So we're going to handle this just like we've done, kind of forgetting the whole numbers, just like we've done in the past. So taking the first one here is 5 times what number equals 45? Well, we know that from doing the slide just a minute ago. It was 9. Whatever goes in the denominator, it goes into the numerator. And completing this, 2 times 9 equals 18. So 18 over 45. Now let's go ahead and add that 1 back in. So it's 1 and 18 over 45. And okay, and now down to the bottom, 9 times what equals 45? Well, once again, it's 5. Pretty simple. And multiplying our numerators now, 3 times 5 equals 15. And add our whole number back in. So now we have a problem where the denominators are the same, and now we can add them together. So now that we have our new problem, 1 and 18 over 45 plus 1 and 15 over 45, we are going to go ahead and add our whole numbers. So 1 plus 1 equals 2. And now our fractional part, well, we know the denominator is going to be 45 because we're never add or subtract denominators. And so now we're going to add our numerators. So 18 plus 15 gives me 33. So the answer to our question right now is 2 and 33 over 45. Okay, well, here we go. We are going to simplify now if possible. So the answer that we had, 1 and 18 over 45 plus 1 and 15 over 45 gives us 2 and 33 over 45. Well, if you don't know, we have to kind of figure this out, and can we simplify 33 over 45? A good way of doing this is using the slide method again. If you remember, slide method will help us figure out what the lowest term is, or the simplified fraction. So let's plug 33 and 45 into the slide. Let's see, what can go into both 33 and 45? Well, I know that 3 can go into 33, and how about 45? Well, if you recall, the divisibility rules of 3 is what you do is you add the two numbers. So 4 plus 5 equals 9. And the divisibility rule says if 3 can divide into 9, then 3 can divide into 45. So I know that 3 can go into both of these. So 3 goes into 33 11 times, and 3 goes into 45 15 times. All right. Now, let's see. Can any other number go into both 11 and 15? Well, I know 11 is a prime number, so because that's prime, and as long as 11 can't divide evenly into 15, which it can't, I know I'm done. And so 11 and 15th is going to be our simplified answer. So we're going to rewrite this simplified. That's going to be 11 15ths. And there is how we do adding mixed numbers where the denominator is different. Go back and check over all of this to make sure you get all your steps down in order.